Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing thin converging lens, paper 1 for core and extended candidates. Before we start, you can find KWL chart to write down what you know, what you want to know, and what you learned at the end of our lesson. You can find it if you join the Telegram channel. Okay, let's start question number 1. But before we start, I would like to clarify and explain some important points. Number 1, thin converging lens. It's also called convex lens. So this is very important to know that converging lens the same as convex lens. Okay. Number 2, when you draw any converging lens, you can find a construction line here. We call it midline, okay, which divides the converging lens into two equal parts. Okay, when you draw a light ray, you will find that the ray will be refracted at this mid line. Okay, in reality, refraction takes place at the boundary here and here. Okay, but for simplicity, we are just drawing refraction takes place at the middle line through the lens, inside the lens, not at the boundary. Okay, but in reality, refraction takes place at the boundary. This is the second point. Okay, the third point, which is also very important, you can imagine that this part of the lens acting as a tiny prism, and also here this part acting as tiny prism. Okay, and we said earlier that if you have a tiny prism or you have a thin prism, the light ray will be refracted and emerge towards the base of the prism. So also here, if you have a light ray, it will refract towards the base of the tiny prism, so it will be refracted and emerge towards the base, and that's why we call this kind of lenses, we call them converging lenses. Okay, so light rays converge because we have another type of lenses, concave, they diverge light rays. Is it clear? Okay, and the other parts also acting as tiny prisms, and the one at the center as if it looks like a rectangular glass block. Okay, so we have here very important point that converging lens, it consists of sections, and each section acting as a tiny prism. Is it clear? Okay, back to our question. We have here the question is asking you which diagram showing the formation of a real image of an object O. So there is a formation of image already. and you have the object is placed in front of converging lens, which diagram here showing this case. Okay, number one, this case A will be excluded. A will be excluded because here the rays, they are diverging, not converging. Here also will be C excluded because we have here the refracted rays, we have extension of refracted rays, and you know that real image, they are formed by real rays, not extension of rays. Okay, back to B and D. In case of you have the refracted rays are parallel to each other and never intersect, in this case no image will be formed because the image is formed by intersection, or the place where, or the location where the refracted rays intersect, you can find the image. So no image is formed in this case. So also B is excluded. Okay, and in this case, by the way, the object is placed at the focus. When the object is placed at the focus, you will find that no image will be formed. Okay, so the answer is D, and the object is located here, and the image is formed where the refracted rays intersect. Okay, so the image will be formed at this point. Is it clear? Okay. Question number 2. The diagram showing an object in front of a thin converging lens and the focal length F is indicated, at which point will the lens form a sharp image of the object. Okay, we have 3 standard rays. We have 3 standard rays. I will explain them in details in the next question, but now I will draw only one of them. We have a ray which is passing through the optical center. Okay, what is the optical center? The point here at the center of the lens. And back to the definition of focal length. What do you mean by focal length? It's the distance between the optical center of the lens and the focus. So this B, we consider it the focal point, the principal focus. Okay? Okay. So when we draw a light ray from the object passing through the optical center, it will be undeviated. What do you mean by undeviated? Undeviated means it will not refract. It will not refract. It will continue in a straight line without any refraction, bending, or without any deviation. So we have here to choose between C and D. Okay, in this case, if you look at the position of the object, because we have different cases, according to the position of the object, you can find the location of the image. Okay, the object approximately is located at a distance double focal length. Okay, double focal length. So at this point here, the object is located, the image should be equal in size. So if I draw an object at this point, you will find its image will be same size, real, and inverted. Okay, so if you have to choose D, not C, because C is very the image will be smaller, not same size. Okay, so you have to revise all cases where the object is located and how to describe the image which will be formed. So the answer of this one is D. Okay, okay. Back to the standard rays. We have question 3 is discussing what we call them 3 standard rays. You can draw many rays coming from the object, and where these rays refract and intersect, you can find the location of the image. But we have 3 main standard rays you have to follow. The first ray is the one we already drew in the previous question, the one passed through the optical center undeviated, this one. Okay, so I call this ray number 2. Okay, so passing through the optical center, what happens? It will be undeviated. It will continue in a straight line without any refraction. Okay, ray number 1 is parallel to the principal axis. Where you can find the principal axis here, this line where you place the object is located. This line we call it principal axis. Okay, so the ray which is parallel to the principal axis, and here it will refract inside the lens at the midline. It will refract here through the focus. To check that the drawing is correct, that's why it's given here the focal length of the lens, which is f. So this point is focus, the distance between the focus and the optical center. This distance is the focal length. Okay, and we have here another focus at the other side also, and you have f is the focal length. So ray 1 it's parallel to the principal axis it will refract through the focus. Is it clear? Okay, the third ray it's opposite to the first one. So the third ray passing through the other focus refract at the midline. So here we have this point, the other focus, and it will refract parallel to the principal axis. Where the 3 light rays intersect, you can find the image. So here we have ray number 3 passing through the focus. What happens? Refract parallel to the principal axis. Okay, our question is not asking you about the 3 standard rays. I am just explaining. He's asking you about which of the labeled rays must have been drawn after the position of the image was known. So it's an extra ray. So you know the location of the image, and then this ray, after you find the location of the image, it's an extra ray after the position was known. So the answer is A, because this ray is just another ray refract and intersected with the other rays at this point where the image is located.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.